Welcome to Packet Pushers Heavy Networking, and boy, do we have a heavy networking show today. We're talking to DriveNets. DriveNets is the sponsor of this episode, and we're getting into a full-blown software and hardware architecture, a clustered network operating system that is more than that. You can do a whole lot with this thing, and we're speaking with Amir Krayden, the VP of Research and Development, and Yuval Moshe, VP of Products, and we get nerdy with it, don't we, Greg?
We sure do. And, I'm not a huge fan of the chassis. I love me some hardware, but I'm really over chassis and the complexity of chassis and how difficult it is for vendors to be able to make them to work well. But I also want to get the reliability of a disaggregated solution. So lots of off-the-shelf components. Can I build a chassis out of those disaggregated components is the question. And DriveNets is exactly the answer to that. Yes, they want to build a telco class, communication service provider, chassis-based terabit class router, hundreds of terabits of class router out of standard off-the-shelf components. And in this show, that's what we're diving into.
It's a chassis without the chassis. It would be a good way to put it. That it grows with you. And again, this is a nerdy show, folks. So dig in and enjoy this sponsored episode with DriveNets. So we want to get stuck into DriveNets here, but this is the first time you guys have been on the Packet Pushers Heavy Networking podcast. So, all right, give us that 10,000-foot overview of DriveNets. Yuval, in just a few sentences, can you explain what the DriveNets product does?
Yes, of course. So originally, the company was actually established to help CSPs shift their network business model so they can actually overcome their increasing challenges and meet, future business needs that they have. The entire product was inspired by the hyperscalers model, which they actually provided all kinds of answers to their unique business environments and their challenging requirements that their industry is facing. If you think about it, what's the major challenge that any service provider has today? That's network capacity growth, right? The growth is actually driven by all kinds of streaming and content-driven applications that we all know of today. If it's 5G, if it's IoT, and everything is really leading to like a giant growth of capacity demands. I would say about 50 to 100% growth year over year. Now, networks in the last 30 years probably hasn't changed much. It's just been built by larger chassis, just grow bigger and bigger and being replaced every 3 to 5 years, but there's nothing new there. It's just that the costs are higher and those operators or service providers just need to pay or spend extra money every time there's growth of capacity. And that's not a viable solution anymore. I mean, the cost of the network scales up with the actual demand.
Right.
You need to find an alternate solution or really simplify the network operation so you'd have both OPEX and CAPEX that doesn't scale linearly with the network.
So what you're drilling into here is the problem in communication service provider, which is telcos or communication providers or network providers, whatever you want to call them, is that typically they go out and buy like a 12-slot or an 18-slot or a 25-slot chassis, and then they try and fill it up with all the boxes, all the interfaces so that they can get the maximum amount of throughput. But that's not very scalable. It's a vertical scale. The boxes are expensive because the bigger the vertical, the more expensive they are. And they're actually not that stable, as it turns out most of the time. So your idea is there a way to break this down into smaller chunks, into disaggregated pieces, and then drive it as though it was a single unit? So make it look like 20 different network devices act like a single unified piece, and throw out the chassis, replace it with a disaggregated bundle.
Yes, exactly. You need to create some kind of a model which is distributed and disaggregated network elements that looks like a single chassis or a single router for the operator, but the entire COPEX, the TCO, the CAPEX that they have for the product itself is much simpler, and it kind of meets their needs, and it actually brings additional value for their future needs. It could be also value-added services and those kind of new opportunities for them.
So this is drilling into this idea of buying an ODM, standard unit switch, a special switch. I assume that the hardware, we'll talk about hardware later, but you've got a special switch that's suited for the CSP market, the service provider market, and you're basically stacking lots of them together to turn them into like a chassis with your operating system and your controller. Is that right?
Yes, exactly. The solution itself, the product is based on two white boxes. One of them would be a fabric, similar to the monolithic chassis, and the other one would be similar to a line card. But using those two white boxes, you can actually scale from a single line card, which is 4 terabits, up to almost 768 terabits, which is the largest cluster that we have, with the same type of white box. You don't need all those types of different routers, different hardwares, different components for various use cases in the network. You can use just a single type of line account for all use cases.
So in the same way with a chassis, when I buy a couple of fabric cards, and then I buy one line card and I'm in business. And this is saying I buy a disaggregated unit, a switch running a particular type of ASIC from whomever I buy it from. I use as many of those as needed to reach the performance that I want. So that would imply that you're also using a disaggregated software strategy. Instead of putting it all inside of one single chassis, now you've got the components spread across all of the units that are in the cluster.
Yes, exactly. In disaggregation, there's actually various levels of disaggregation. The first one is what you mentioned about hardware. Naturally, you disaggregate software from hardware. Now, that's not new. I mean, it exists in the world for several years. It's been done mostly in hyperscalers in x86 environments. But when you're talking about service providers, the scale and performance needs to be much higher. That's in terms of the hardware versus software. When you're talking about disaggregating the software, then you're separating control plane from data plane. I mean, we're using x86 off-the-shelf servers to run our software on top of that, which is container-based, similar to hyperscalers approach. And we're running on the actual white boxes, we're running containers, which their main function is actually to run the data plane features. If you take, as an example, quality of service, access lists for security, and those kind of things.
Okay, so we've got the idea of disaggregation, and then the operating functions are distributed across all of all the devices in a cluster. And let's just bring this around to where the service providers would be interested in this. And that, again, is because I'm building it from disaggregated pieces of ODM equipment, my CapEx is lower. I'm building white boxes with merchant silicon, standard off-the-shelf components. And I'm also able to buy it in chunks. I don't have to buy one big chassis and go to town. I can scale horizontally. I can increase it piece by piece. Is that right?
Yes, exactly. Now, if you think about it, we spoke about what's the main challenge that they have today, which is mostly the network capacity curve. Think this one actually relates to three main topics that they have to deal with, or three main issues that they have. First off, the installation that they have today in the network has very low resource utilization. It's actually, their network is segmented to all kinds of dedicated physical network sections per type of service. If you think about it, mobile, broadband, enterprise, each one of them has its own segmented network using different types of routers, and not a single white box or a single vendor that supplies for all different use cases. That's the first one. The second one, the complexity. Multiple networks, multiple types of use cases. The operation complexity is huge. There's different types of router types, software releases, hundreds of actual components. For each one of those routers, you need to have a different type of fan unit or PSU, which means you need to store them in inventory and you need to save them for spare parts. And lastly, it's high cost model. The entire model that they have today, both from CapEx and OpEx perspective, as we mentioned, just scales up linearly.
So basically what you're trying to do is step out the capital expenditure so that you've got just the capacity that you need. You're only burning up space for exactly what you need. You're not putting in a big multi-slot chassis for the day that planning in 10 years' time. You're just using up the space that you need for now. You separate the control planes and the data planes so that you've got the routing protocols are separated from the forwarding planes. I guess that would be a requirement of the architecture, really, wouldn't it?
Yes, exactly. If you want to support a disaggregated model, you have to have some kind of a separation of software both on control plane and data plane. Because you want to run the compute resources externally on x86 dedicated or actually off-the-shelf server, and you want to have the white boxes act as single entities that can run their own use cases.
There's a point of clarification we need to make here. You know, we've talked from a hardware perspective about white box switches. I believe you guys have a partnership with Broadcom. We've talked about x86 machines. If I'm a service provider, of course, I also have a huge investment in a ton of, I don't know, I was going to say legacy hardware, but that's probably a bit harsh. But, you know, the big routers and switches, the big iron out there that we've been talking about that's so expensive and such. is the DriveNet solution completely separate from all of that hardware I already have installed, and it's kind of like a greenfield thing where I can add capacity to this new thing, and my existing network is something else? How does this all fit together?
So that's a very good question. I think that's one of the questions that operators or customers always ask us: how would they actually deal with that new network, because they don't really have a greenfield. So our suggestion always is to use some kind of a migration path. We install in parallel our solution, our clusters, and if you think about it, in most of the service providers today, most of the network, or if you actually bundle their entire capacity in the network, it doesn't even reach a single cluster that we provide. So it means when you install our solution, you start taking over the new growth in the network and slowly merge what you mentioned as legacy router or legacy use cases, merge them to the new network. So within, let's say, a year or two, you're pretty much done with the old network and you moved everything to the new network, which is less equipment. It could be large clusters that handle the entire capacity of the network.
And adding one more thing to that is the beauty of the fact that maybe it's not a new problem. Had you go out and buy a very new incumbent vendor, a very large router, and you had an old one, they're not speaking to one another. So you faced with that problem as well. Your migration plan, your move towards how do I build a new network, which is one on top of another, one aside of another, will always be there when you do giant leaps in technology.
Right, because I invested in some particular chassis that solved a problem I had 7 years ago. Nowadays, I need to go to some completely different and new architecture that impacts my spending, that impacts my inventory, that impacts how I do operations. So you're making the point that if I go DriveNets, it's not like that's creating a new problem for me. I have that problem anyway. But with the DriveNets approach, now I'm building out a disaggregated model. I'm building out a model where I can unify my operational approach. And I think another point here that was interesting that kind of came up in passing as you guys were introducing this, I have now flexibility to build out new applications in a way that maybe it was more difficult to do that before. And I think for service providers, that's a really big deal because the network is the business if I am a service provider. So being able to build new applications that generate revenue for me is a really big deal. Can you talk about that a bit?
Yeah, I think Amir maybe can add shed some light about how we actually support value-added services in our architecture.
Yeah, so first of all, the fact, and we'll speak about it when we are speaking about software architecture, the fact that we've completely disaggregated control from the data plane gave them few benefits that they never had before, even before value-added services. If you speak about what a service provider needs to do in order to enrich his own offering, would be mainly to go into the control plane and add functionality. When you're doing it on top of a chassis, you're going and touching the device itself. When we took the control plane out, first of all, here you have a very nice room of innovation in which you can update this control plane without touching any hardware. You're upgrading a VM, you're upgrading a Docker container. It's a much easier approach than you've ever seen before. Again, when we'll speak about software architecture, our view is not having yet another network operating system. It's but having a virtualization layer over the white box as a virtualization layer over the compute. And now when we look at it this exact way, we open up a very nice new field. If I have a DDoS mitigation, which I want to do, maybe part of it could be on what we call the line card, the white box. Maybe part of it can run on our control. And it's much closer to the networking environment. If someone going to do a 5G application, which needs to be very, very low in terms of delay or jitter, we can run his Docker container on top of our architecture. And for sure, looking into the future, looking into hybrid clouds where service provider can offer not only services in their big central offices, but also at small central offices, this is a great room for innovation.
I think also the trick here is that you're also using a modern approach to the operating systems on the devices as well. So if you're focused on if you've been using the big chassis-based routers for the capacity and the forwarding, you've had a lot of things said to you about software quality and promises about how it operates. But what you're doing is using the container-based model. And as far as I understand it, correct me if I'm wrong, you actually break down the components into small containers so that you can actually solve the problem of software compatibility and software interactions in smaller pieces. It's not a monolith. It's a microservices-oriented architecture in that sense. And does that improve the usability for customers?
I think there's two layers to what you asked. First of all, you described it completely correct. One is now the price you have to pay in order to bring new features into the system is much lower. You're not going into an upgrade, a complete full software upgrade of a very large chassis. You can upgrade this exact Docker container, which give you a whole new world of how do you patch, do you do patch management in operational environment. So exactly as you said, I think the most beautiful thing in the way that we've solved it wasn't looking at something like Cisco's iOS XR or Juniper Junos and saying this is the way a NOS should be built, but to a very large extent, looking at how web applications are being built today. And they're very resilient, they're very highly available. They just solve the problem in a completely different way.
All right. Well, that might be a good question to lead us into a high-level overview of the software architecture. Then we sort of laid out a bit of a pathway there.
Yeah, Greg, I think we need to go there because I was kind of playing back what we've been talking about in my mind. It's like, okay, we've got this separation of control plane and data plane, but then we're talking about where different containers could be running, and it could be in either place. So Amir, I agree. I think we got to back up a bit and talk about that software architecture again, so it becomes a little more clear in our minds where all these components are and how they interact.
At least for the beginning, try to visualize a chassis and visualize a standalone box and ask yourself one very important question. Is there any difference? Do I, as a software vendor, really want to see a difference between how I operate my software on a 16-line card router or a single line card router? And for us, it came into mind very early that we absolutely do not want to see any difference. We want to see the exact same software stack functioning the same. So the way to vision it is now a line card might be a logical function. It's a card that does forwarding. If it's a standalone box, on the same standalone box, I have an ASIC that does forwarding. The same exact problem. My control plane running BGP, running ISIS, running OSPF or traffic engineering protocols. It can run on an RP if it was a chassis. It can run on box if it was a standalone box. And it can run on both. If I have a very large cluster, I have BGP running on the server and I have the line card functionality doing the forwarding. So from our perspective, the beauty was to solve it the exact same way.
Yeah, and I can actually put your software on an x86 box as much as I can on an ODM, Broadcom, ASIC switch, or, of any sort. The same software applies in every case.
Completely correct. When DriveNet originally started, we've been building a lot of VNFs, a lot of virtual network function. We've built our own layers of forwarding, and today we keep the exact same interfaces. So my solution running over a native x86 and running over an ASIC would look exactly the same. Essentially, the way that we measure how good our design is, the way we measure how flexible it is by the ability to go between platform, going between ASICs, doing exactly what you said. I think this is the beauty of the solution. This is how we should be measured.
Yeah. That flexibility is something that interests me because I think increasingly the network doesn't stop at the edge of the Ethernet port. It goes right the way into the VM or into the server itself. Or you may actually want to use software as a forwarding plane for some reason, and that flexibility. So you mentioned cloud native along the way. What does that mean in the DriveNet? Because a lot of companies talk about their application is cloud native, and it normally means they've got a container in it, and that's usually enough to qualify as cloud native. What does DriveNets mean when you talk about cloud native?
We mean, first of all, that we started from looking at the problem as a microservice-based one. I'm not doing a line card. I'm doing a forwarding service. Whether this forwarding service reside on an ASIC, whether it reside on an x86, it doesn't matter. It has a functionality of forwarding packets. And I need to look at it as an orchestration problem. If I'll take you back to the problem of a router, we'll take a protocol like LACP, for example. This protocol controls a single port. I don't need to run it on the server. I need to know that this protocol is relevant at an exact point, which is in our case, the white box.
You don't even want to run it on the server. There'd be too much latency introduced to that specific process.
Exactly. But if you look at the inherent problem, it's an orchestration problem. Where do I put the service so it's best fitted into the function it needs to serve? And this is cloud native. meaning it's much more than running a Docker container, but having the intelligence to put the Docker container at the right place to optimize from system perspective what we're trying to achieve.
Yeah, I think, Inten, you mentioned something which is quite important, the latency impact. If you remember, there was, for several years, everyone's been talking, mostly the telco providers, about SDN and how SDN will change their life because they want to adopt what they saw in hyperscalers, but the latency actually killed it. You can't really put something which is, I would say, RSVP, fast reroute orchestrator or controller externally out of your network. I mean, the network has to be on-prem and someone has to control it locally so you can have fast reroute capability.
You need to be able to react in microseconds or milliseconds at worst. Yeah.
Exactly. That's why SDN kind of moved most of the orchestration features, which could react at a later phase, and we kept all the local capabilities on the actual x86 on-prem on the cluster itself.
Mm-hmm. That actually brings up another question about this as we're talking about cloud and this disaggregated model. Does my control plane live on premises somewhere, or is it actually up in the cloud somewhere?
So essentially, we can do both. Usually, when we're looking and speaking with our customers, from DriveNet perspective, you can run your own control plane wherever you want. But if you look into Sense and you look in where would be the right place to put it, we need to remember that there is interaction between the control plane and data plane. Eventually, a BGP packet coming from a line card, from a white box, going into my control plane needs to traverse some networking environment until the point I reach the protocol and handle it. So from a customer perspective, it would be beneficial to minimize this delay. So in this case, you can call it on-prem. But another benefit that we bring into the service provider market is now it doesn't have to reside in the same room, which is also a leap forward. I can have my control plane running in an quote-unquote IT environment on very strong servers residing within dedicated servers rack, and the rest of the white boxes in the telco space. So I get low delay, but I also get the benefit of handling the function in the right place.
It's an out-of-band network, but for the control plane instead of just management traffic.
Exactly.
Yeah, on-prem doesn't have to say you win the chassis. You might be in the room or in the floor.
So, I got another software architecture question for you guys, because we talked about, you made the point very clear that I can run DriveNets on an x86 box. I can also run it on a box that's got Broadcom ASICs in it, let's say. So that tells me you've got an abstraction layer in there somewhere. So did you write your own abstraction layer, or is there one of the several that are available in the industry that you're taking advantage of?
So we're completely open in regard to that. First of all, exactly as you said, we have a very strong abstraction layer. Nowhere inside of our architecture, until the point we're really at we're at a really low level of the white box, do we translate to any ASIC format. In Broadcom case, it's only very low our architecture that we translate from the DriveNets quote-unquote language to a Broadcom language. The rest of the system is completely model-driven, meaning that we've defined DriveNets Yangs in a strong community with the Open Compute project. And essentially, we speak at the DriveNet language. We program a queue, we program an ACL, we program a route, but only at a later stage would we translate it into the ASIC itself. So for us, if someone brings in a new ASIC tomorrow and it's good enough and it has all the capabilities that the service provider needs, great. We will be more than willing to migrate it and test how fast we can do it.
Because all you got to deal with is the translation service. You don't have to rewrite fundamental code.
Exactly.
Yeah. Yeah. Okay. But it does sound like then you wrote yours. You said DriveNets language. You've got your own Yang modeling and so on. And so your abstraction layer is yours.
I heard was you wanted to be in control of your own destiny. You didn't want to be beholden to the ASIC providers, and you wanted the flexibility. Is that a fair assumption?
That is a fair assumption, but also, yes, we wrote our own abstraction layer, but the Yang modules, where we can be standard, where there's an IEEE draft, where there's IETF draft, where open config define it, great. We want to be as standard as we can, because we have the benefit of people adapting it much quicker, and it works. It's just win-win situation for everyone. But the industry, this industry, you live it as long, at least longer than I am. Not everything is standard. Not always did we see a Yang module which defined correctly RSVP or traffic engineering or segment routing or anything else that we're trying to do.
Yeah,
I was going to be mean and say, but there's so many standards in the Yang world. But you just said it for me, kind of.
It is exactly a non-standard standard world.
Yeah.
Yeah, the kind of thing we were all afraid was going to happen. But as you pointed out, there are certainly a number of Yang model libraries that folks are rallying around. And as you say, if you supporting those as best you can, and that's as expected, right? And especially with you, you invoked the Open Compute project. So I would anticipate they'd really insist on that anyway. Well, you've got an API in this thing, which again doesn't shock me. But tell us about the API. What could I do with it if I'm a service provider trying to integrate DriveNets into my operational world? Let's say.
Mm-hmm. Excellent. So think of the API as kind of encompassing more than one thing. One form of API would be protocols, standard one that we support in order to enrich the service provider environment with the abilities to do software-defined networking. So things like BGP link state, which would give you the topology, or PSAP in order to control your traffic engineering. So these are standard APIs or protocol which lets you speak with the DriveNet platform and configure it or provision it. Part of that, of course, things like netconf in order to do netconf configuration. But more than that, we've developed a set of open APIs which we expose to our customers, both at the router level and at the orchestrator level, that let you control the system from an orchestration perspective. For example, deploy the DriveNet software, upgrade the DriveNet software, get matrices that you otherwise probably couldn't out of the systems. So we really enrich your environment in a way that let you automate over the DriveNet solution, probably in a much better way that you could have done so far.
So there's a northbound and a southbound API, I think I just heard you say, because I can talk to the orchestrator and get things done that way, but then there's also southbound from the controller down into the data plane?
Mm-hmm. Exactly.
So there's a question here. If I'm reading and writing to an API and my DriveNet software is clustered across multiple devices, and I have this in my mind, 20 or 30 devices in a single cluster to be equivalent to a chassis-based router, you must be able to synchronize that very quickly between all of those devices. Do you want to talk about that at all?
I think it's a wonderful question, and it should be a very simple answer. It should look exactly like programming any other router. The fact that there's 20 boxes there shouldn't matter. The fact that there's 100 boxes there shouldn't matter. If you configure an ACL over a log bundle and that log bundle spans over 20 machines, why should you care? It's DriveNet's problem to make it. It's DriveNet's problem to make it look as seamless as we can to be done in a transactional way.
Because in the chassis, that's often done with mystical magic. And, they actually have out-of-band buses and special cards that distribute the communication between the control planes is actually done on. You're in a distributed open environment. You're doing it in some way. All I really want is an assurance that, yes, when I program an API within milliseconds or less, that is the cluster reaches a point of coherence and stability.
Well, I think it's not that mystical. If you think about it, essentially what they have internally is just a management switch. Now we have the same part, just disaggregated within our solution. We have a dedicated switch, and his sole purpose in life is to forward your API calls to all other devices in the disaggregated chassis. And what Amir mentioned about having a transactional API is exactly the type of you would call magic that makes it happen, right? You forward those calls to all of the devices, and they all immediately acknowledge that they accept if it's either a fib programming or a new configuration that they need to apply to all of the line cards at once.
I get it, right. So that makes perfect sense, because that's straightforward. Then there's a dedicated communication pathway, and then your software will be coherent, because the only thing that that is elastic now is the processing power of the coherent protocol that you're using between the switches.
Yes. Yeah. Exactly.
We're talking about we're talking about the control plane, or I don't know, the orchestration layer specifically, right? As far as this cluster goes.
So if you think about it, Amir talk about how do you actually program or configure a monolithic chassis. You just use CLI today. I mean, there's not a lot of orchestration or external management system, but within our solution, if you think about it, we brought to the table something that didn't exist in the past. When you insert a line card into the chassis, it's already there. There's a slot, it's numbered, you just put the line card in and everything works as planned, right? There's nothing special you need to do in the field. It just goes live and you can start using that line card. In our solution, when it's disaggregated, you have to connect it in some way to the disaggregated chassis, and something needs to manage that platform and make it part of that cluster, because otherwise it's just another white box. So we actually introduced our, we call it DINO, DriveNets orchestration system, and its purpose is to actually run the lifecycle management of the product. When you plug in a new white box, it actually calls home what you would known as ZTP, and it immediately gets the software, gets validated. We know it's part of DriveNet solution, and it's part of the cluster immediately. So from that point on, deployment, upgrades, lifecycle management, and everything works seamlessly like a single router.
So the cluster then is distributed across all of my devices that are running DriveNets software. So I plug in a new x86 box, I plug in a new white box switch. They're all part of participating in this control plane cluster.
Yes, if you take let's take a service provider network. Usually in a large CO, you would have two large routers just for redundancy perspective. Each one of them could have, let's say, 16 line cards. If you take our solution and try to put it on the same site, you would have the same thing. Two clusters, each one of them could be, let's say, even up to 48 line cards. And every line card that you want to connect to one of the clusters, you just do use the orchestration system, connects it to be virtually part of the chassis, and you have two running routers at the same time.
Okay, this brings together an idea in my head here that you have said it earlier in the show, but it really cements it. I'm really dealing with one gargantuan switch the way this all goes together. Well, is that the only way I would architect it, is one massive switch with as many line cards as I have devices, or would I actually split this up into different domains somehow?
It's actually it depends on the use case. If you take a look at the segments that you have in the network as a service provider, it starts from the last mile to access, maybe metro, aggregation, access, and then peering and core network. And the main difference, other than the, I would say, pop of under the pop sites or the connectivity of the services, is the scale. Usually, if you talk about New York City, naturally you'll have large site there with a lot of capacity. And if you're talking about some remote site in North America, you're going to have very low bandwidth for capacity. So it's up to you, the provider, to decide what's the scale you want to use. But the benefit here that you don't have to pick and choose up front and then you're stuck with it for 5 years and you have to do some kind of a forklift replacement. You can use the same line card, which supports 4 terabyte. Or terabit, you can use it as a single line card, just as a pizza box, standalone box, and put it in some remote site. If you want to move that exact box to New York, because now you need another line card, just move it there, connect it virtually to the cluster, and that's it, you're done. So you can use the same solution in any site or in any location that you want. You don't have to replace the entire cluster.
Okay, my brain just broke a little bit. Guess what I started thinking about was, wait a minute. So with this architecture, the flexibility I have to design things gets really interesting. Like I could do something, I'm not saying this would necessarily be a wise design, but I could do something like, all right, I'm going to stack up in this one pop 100 devices with thousands of ports and have it appear like one BGP router on the network. That's a thing that I could do, it sounds like.
Yes, think about what happens today. Well, everyone's talking about COVID-19, right? But think about what happens. We're all watching Netflix and YouTube, and we're always streaming now. We're watching live from home. Now, what really happens in those POPs, in those service providers? From supporting 10 terabits in a single location, suddenly they need to support 50 terabits in a single location. And the only way to do it is start buying more chassis because they're out of room. And if you stack everything today and just add more and more and more bandwidth to the same cluster, you don't have an issue. Just add those line cards.
And that chassis is still a traditional ECMP. So the physical infrastructure in there is still an ECMP type design. Traditional 2-tier ECMP. It's not some radical loop or, optical trigger. It's just a straight up Ethernet fabric, ECMP. It's the software is where the focus is. I just wanted to cover that in case we hadn't mentioned it.
So do people stand this up in like a leaf spine sort of topology typically, depending on what they're trying to achieve?
Essentially, the way to look at it from a physical standpoint is that you take the fabric white box, you take the line card white box to say, and you do put them in a class formation. But from that moment on, once software is provisioned, software is deployed, this is one big router. And had you ripped open a chassis, behind the scene, this is a class network as well.
Well, right. Yeah. We've actually got a presentation on our YouTube channel that explains that, exactly that. When you tear open a chassis switch and actually look at what's going on, right, it's a crossbar fabric in there that you're interconnecting those line cards and such. And so effectively, in other words, there's got to be a smart physical design that underpins the flexibility of this architecture so that you're not subject to a poorly thought out cabling, or some such. You really do need to think about those things, that those matter. But then once that is in place, leaf spine, presumably, limited or at least well-defined and understood oversubscription between tiers. And now, right, I've got this massive switch that I can do things with. Well, router, switch, whatever we mean these days, Let's talk about money, guys. Let's talk about money. So, because service provider networks are notoriously expensive, these are big dollar networks. They're large, they're spidery. The bandwidth's expensive. It's all expensive. And so, how do you guys fit into this? Because cheap to buy. Like, I guess you're saying that you're fairly inexpensive to buy compared to a traditional model. But does that also mean it's cheap to operate? Because it doesn't necessarily. And to be fair, some of this sounds. It's different, and part of my brain's going, is this complicated? Is this more complicated to have, an external leaf spine versus a, collapsed chassis where it all tidily fits in the rack? So anyway, talk to us about money.
Yeah, so when you take a look at the overall TCO, so our overall TCO is much cheaper than naturally what you have today in the incumbent vendors. Some parts of it is the operation, as you mentioned. We'll talk about it in a second. Some part of it is naturally because of white boxes, right? Because overall, when you're not dependent on a single vendor and there's no vendor lock-in, and you have other ODMs that they can reduce their costs, and naturally there's a competition in the market, then the customer eventually wins, right? He gets to pay less. But let's talk about operation. I think that's a myth. There's a lot of telco providers and customers that's the first thing that come into mind, mostly in engineering, that says, look, it looks huge, it looks complex, it looks like we're going to need extra systems. I don't know if it works as a single router or 20 routers that now I need to operate in my network. And our answers to them is, let's take a look at the bright side, and let's take a look at the entire solution and see what it actually brings to you, or actually brings to the table when we're talking about the operational complexity. If you take a look today on a chassis, and you're out of capacity, and there's, let's say, 8 slots there, and you need slot number 9. There's only 2 ways you can really solve the issue today. One of them is go get another chassis and do forklift replacement. And forklift actually means forklift. You need to bring a forklift to take out those gigantic chassis, move them aside, and bring something else in. Or the other way is to introduce a new router to your network, which has his all entire problems of introducing another node into your complex IGP or MPLS network. In our solution, it's just a white box. It's a pizza box. It's exactly as it sounds. Just insert another small pizza box into one of the racks in the room, plug it in, and that's it. You're done. So from complexity perspective, you're pretty much 50% cheaper not for the actual service provider, but for the company that actually builds it for the service provider. They don't need to bring the forklifts anymore. That's it. All they have to do is store it in some warehouse, send some guy in the middle of the night with just a simple pizza box. He can bring it in his car, open the back door, put it back, and just insert it to one of the routers, and that's it.
You don't need a hydraulic jack to lift it up.
Exactly.
And you don't need 3 people. You don't need special screws. You don't need to worry about weight on the floor. I've had to get special dispensation from colo providers to validate that the weight distribution on the floor was correct, because one rack was so heavy that the network kit was so heavy that I had to have it placed in a particular place in a data center where the stress wouldn't cause the floor to collapse or something like that. These things matter much more than we think.
They matter a lot. They matter a lot. If you take a look at the chassis today, it's not really limited by the actual capacity that the chip can handle or the chassis that the vendor can manufacture has a limit. It's actually the cooling and the power that they need. If you have a huge chassis, you actually, the entire room is actually empty. All you have is that gigantic chassis in the middle because there's not enough power or not enough cooling in the room. When you do it, I would say hyperscaler or data center style, you just distribute those boxes around the room and you have enough cooling and enough power for the entire solution.
Another point here is that management didn't get any more complicated for me just because I've added more devices. That is, I didn't come up with another mouth to feed. It comes up, ZTP, joins the cluster, and now it's part of the collective that I'm managing centrally anyway. So I've added capacity, but I haven't added, like I said, another mouth to feed.
Exactly.
Yeah.
Yeah, go ahead, Amir.
From your point of view, you see another line card in a virtual chassis. You operated the way you always did. You configure it the way you always did. You get the same syslog. You get the same SNMP if you want to use old method. You get streaming telemetry if you want to use new method. But from your point of view, this is a single entity. This is the exact beauty of our design.
Yeah, but there is one key aspect here that you're saying we need to match the legacy network, as Amir is saying, like SNMP and CLI, because you know how it is. Engineers, we want to be engineers. We love the CLI. I still use CLI because I love it. You want to see the commands, you want to see the output, want to see what's going on. Everyone still loves CLI. That's not going to go away. We still develop CLI. But on the other hand, when you want to match hyperscalers, when you want to see what's going on in the cloud networks, you want to see orchestration. If you want to have value-added services, you want to see DDoS, you're not going to do it with CLI and do some kind of a grep package from internet. It doesn't work like that today. You want to see orchestration system. You want to have some kind of a marketplace where I click a button and the entire cluster just gets upgraded. And that's how it's done today. I mean, that's from operator perspective, that's mind-blowing. They're saying, wow, that's a whole different way to actually manage a router today.
But your solution would snap into whatever OSS or BSS the communication provider is running. You're not telling them that you have to come and buy my special magic multi-million-dollar orchestration platform and run it with my custom hardware and my custom operating systems. You are indicating that I'm going to give you a replacement for this massive router that you have, this particular pain point, which is this multi-slot routing engine with very large forwarding performance that has a large number of interfaces. I'm going to replace it with this disaggregated solution. I'm going to give you an operating system that brings it all together and makes it look like a single thing. So it runs and just like your network does today, you still see one chassis, you see one API point, you see one control plane, even though it's clustered or unified across multiple devices. And then you bring whatever OSS, BSS you want. If you've got an in-house developed one, you just send, standardized API calls where the standard APIs exist, whether it's RPC or Yang or whatever, and you'll configure the system accordingly. And then, and you're almost, the vision I had when I was reading and prepping for the show was a duck paddling. It looks like a duck on the top, but underneath there's all this stuff happening to keep the clusters going and bring together this ODM into a unified whole. And I think that's the trick here, is to see this as instead of it being a chassis, it might be 20, 30, 40 ODM switches, but it looks and operates like a chassis switch or a chassis router, chassis-based router.
Yeah, I thought you were going to say it looks like and operates like a duck, but it's shut.
Is there a scaling concern here? Like Greg, you just happened to mention in passing, 10, 20, 30, 40 switches. I mean, how many switches could I join to the cluster and have it work?
Well, each white box today is 4 terabits, which is actually limited by the chip, the silicon that Broadcom supports today. So it's 4 terabit today, and we support up to 48 of those. So it's 192 terabits, which is much, much more than what service provider needs today for a single router. And it's actually designed to support almost 800 terabits. So there's pretty much almost 200 line cards under the same router. Now, admit it's not in every corner, in every CO that the CSP has, right? But keep in mind that the same box can be used anywhere using the same fabric and line card. So you just buy one solution and place it wherever you want.
So this is a production solution at this point, or is it kind of like beta testing with key customers? Where are we at?
So today we actually have a deployment in one of our North American service provider, and we're working with pretty much all the big tier one providers in the world because they all experience the same issue, and the solution and the product is actually well accepted by all of them. So we're in testing in several places, and we're already in. Running.
So if I was a customer and wanted to see, talk about real world scenarios and talk to other customers, you've got people I can talk to.
Well, essentially, naturally, you can contact us whether through your podcast, through our, everyone goes through LinkedIn or for our website where you have pretty much all the information you want to see there. There's overview of our product solution. There's references for all the product, podcasts, webinars, and various, analyst reports and those kind of things that actually talks about disaggregation and our solution that matches kind of the future of IPNet.
Talk about licensing real quick. It sounds like, since you're already in all the tier one players and such, there's a cost model there that's attractive. It sounds fair to say.
Yes.
No one expected the increase in capacity demands to happen, you mean, because of the global pandemic. Yeah.
Exactly.
Exactly. And I think even one more comment here is the fact that if you're a large service provider, you can look at the beauty of seeing it as software license and not as a perpetual license. You don't grow the payments you pay does not grow at the rate of you putting new routers, new hardware. We can go into a fixed model in which will pay us a fixed amount of money year over year for a certain number of years. It to begin with. No matter how large, no matter how steep would be the jump in your traffic, you would not jump in the payments you pay us.
You wouldn't have to pay a tax. I call it a tax. As you sell more bandwidth or offer more bandwidth to customers, you have to keep paying. And the trick here is, of course, for communication service providers, is they don't necessarily generate more revenue from more bandwidth. So it's actually a trap for communication service providers to be caught into, the licensing cost increases, the capacity increases. It sounds perfectly reasonable until you realize that in communication service providers, you don't get more money for the bandwidth. You get the same money for more bandwidth.
Yeah, I can tell you a story about what happened here in Israel a few years ago in the cellular industry. I mean, we paid a lot of money, I think almost in the States, about $80 a month just for our cellular build. And some company came in and kind of broke the entire market and they offered something in $10. A year later, everyone pays $10, and those providers, they haven't changed anything. They still need to meet the demand. So the solution for them would be the same thing. They need to lower their OPEX and CAPEX costs on their network.
People miss that. People forget to take that into account. And paying for your vendor suppliers as a taxation model, that is, the more you earn or the more you consume, you pay more. There's actually a catch in the back end there. As long as it's linked to generating more revenue, it's fine. But in the communication service provider industry, that's not true.
Yes, that's right.
Now, as I was doing my homework for the show, I noticed that there's some involvement that you folks have with the Open Compute project. And since we're talking about licensing and purchasing and all that, this seems like a good time to bring that up. What are you offering to the Open Compute community?
So our software and our entire architecture is completely compliant with a concept called DDC, the Distributed Disaggregated Chassis, which was offered by AT&T. And was accepted to the Open Compute project. And essentially, the beauty about it is not only that it materializes this design for service providers, but it also brought it into reality in the fact that more than one ODM vendor took it, and more than one ODM vendor was willing to create it. And for us, this opens a lot of possibilities, lowering the price because there is more than one vendor. But also from a service provider point of view, they're laying the ground here for a bigger thing, running DriveNets and running other companies who would be willing to run in such architecture, offering new services, extending existing services. So from an overall perspective, this is a great move. And OCP for us is important not only because of this specific hardware, but also for other things which are important for cost. Optics. We do not brand optics. So any OCP compliant optic would be working here. It will be certified. It will be part of the solution. So from the grand scheme of things, this is lowering the cost in many, many aspects.
Hey, just some business advice. If you guys make your own optics and brand them and then mark them up like 1,000%, maybe 2,000%, and then make it that's the only one your customers can run, there's so much money to be made there.
I think that's what other vendors thought of at the beginning.
Ethan, I think somebody's already thought of that model. Buddy.
I'm behind.
Good idea, but
yes. Man, I missed it.
You do know there's a hidden command for every SFP to be running the network, right? That's kind of the magic that happens in every vendor.
Yeah, we've heard all about it. Yeah, it's scary how little the differences are. But so okay, with Open Compute, then I can buy off the Open Compute list. I've got multiple vendors that are writing or making hardware to that spec that you support. So, like you said, that's important to you. That just makes it easier for you to integrate into that ecosystem.
Exactly.
Okay. Well, let's talk about roadmap if you can. I don't know if you've got anything big on the roadmap that you're able to share, but that's always a fun question to ask. What's coming next?
Okay, so we're talking about service provider, right? Service provider is a unique market, and it has its own demands, it has issues, and there's different segments within that market. So we support today the core, some of the aggregation and the peering functions or use cases within that market, but we're working to expand that to other sections within the market. If you're talking about metro, access, last mile, those kind of segments within the same market. Now, that's one market. Naturally, like any other company, we're trying to expand our market, and our strategy is to kind of focus on more use cases that you see today, like 5G and IoT and mobile backhauling, and all of them experience the similar issues of having to run disaggregated types of architectures, and our software and orchestration really fits there very well. So that's two kind of main paths we're working on in parallel.
And of course, important note here is the enterprise market. You need a lot of ports, you need a lot of interface. Here's a great solution for data center interconnect, or for your pod, for your super spine. A lot of very other interesting elements that we're going to tackle in the near future with very much the same offering.
Yeah, you mentioned OCP, by the way, which is a good point. There's not a lot of vendors today which manufacture commodity chips or commodity hardware to support that white box model, but we're obviously working with the industry to expand that as part of our roadmap as well, whether it's new optics, new white boxes, new chips that's going to come in the future with the vendors or the partners that we work with today. That's naturally part of our roadmap, because there's going to be new line cards, new fabrics within a few years as well.
All right. How do people find out more? It sounds like, well, if you've got a page to drive people to, or just a website or blogs, anything you want to let people know so they can find out more about DriveNets, how do they do that?
Yeah, you can actually access our website, DriveNets.com. You have the complete overview of our products, solutions, references to pretty much every podcast, webinar, various analyst reports on our solution, or whether our customers, how they see our products. So you can just log in, take a look at what we offer there, and there's always contact us if you have any more questions.
Very good. And I've got a couple more URLs if you're out there listening, drivenets.com/resources. And there's a network cloud white paper that you can consume as well. get.drivenets.com/network-cloud-white-paper, which you will not remember because you're driving in your car, I hope. At this point, you're going back to work. and so don't worry about remembering it all right now. Just go to packetpushers.net, do a search for DriveNets to find the blog post for this show, and all the links for all of these resources will be there for you. And you can find this show and, again, many more free technical podcasts, our community blog, etc. All of that is at packetpushers.net. We're on Twitter, so you can keep up with the shows and communicate with us. We're at Packet Pushers. We do monitor that account. We do respond to your questions and queries and so on. We're on LinkedIn as well. And rate us on Apple Podcasts if you would. That helps us out. And last but not least, remember that too much networking would never be enough.